Hi, everybody. Today we're going to do P4, which is evaluating variable expressions for number sequences. And the thing here, I'm so glad I looked at it ahead of time because there's two ways of looking at this, and I'm going to show you both of them. Hopefully, you'll be able to use my shortcut by the time you get to the end, and we'll get started. P4. I usually like to make it a surprise, but this is a really good one. So the whole idea here is that we are going to look for the terms of a sequence, and I'm going to go ahead and write it formally as A1, A2, and A3. These are the first three terms in a sequence, and we are saying that A to the n is equal to 2n minus 8. We usually write the n large over here and small over here, but it's the same n. So in this particular case, you've got 2 times 1 minus 8. And in this one, it's 2 times 2 minus 8. And in this one, it's 2 times 3 minus 8. This is the first, second, and third terms in what we call an arithmetic sequence. So let's take a look. 2 minus 8 is negative 6. That's the first term. 4 minus 8 is negative 4. That's the second term. And 6 minus 8 is negative 2, which is the third term. Now, that's the long way to do this. The short way is to recognize that this 2 is behaving just like the slope on our slope-intercept. In other words, for all these y values, these are the inputs, by the way, 1, 2, and 3 are the x values we chose to input, or in this case, the n values. N standing for integer, and the negative or possibly natural number. N could be natural numbers because that's really where we start at 1, 2, 3, 4, and so on. So we started at negative 6. That was our first term. Now to get to the next term, which are these are y values, or sort of like y values, we could have just added the 2, couldn't we? Do you see that it's going up 2 every time? So our next term would be 0 and our next term would be 2. And it's a lot quicker than evaluating all of these. So anyway, that's what you could do. We've got negative 6, go up 2 to negative 4, and we go up 2 more to negative 2. Okay, so let's take a look at the next one. Now I think they're going to alternate with geometric sequences. Now geometric sequences work like this. We have shall I write it formally? A to the n is equal to 2 to the n. And we want, oh, well, sorry, that's not true. That's not correct. It's this, a to the n is equal to 2 to the n. And we want a1, a2, a3, and a4, which of course is 2 to the first, and that is an ugly 2. Okay, try again. 2 to the first, which is 2. 2 multiplied 1 time is 2. 2 to the second is 4. And 2 to the third, be careful, is 8. We're doubling it every time. And 2 to the fourth is 16. Now we could have multiplied these out each time independently, but notice that we're multiplying by 2, we're multiplying by 2, we're multiplying by 2. This is a geometric sequence. So we have a multiplier, we have a common multiplier. And since our first term is 2, to get the next term, we multiply by 2. To get the next term, we multiply by 2 again. And to get the last term, we multiply by 2 again. So hopefully it's clear what I'm going to be doing for my shortcut. Occasionally, I'll do it the other way. Now my first term here is going to be 3 times 2 to the first, which is just 6. And then I'm going to multiply by 2 every time. Notice this is not the same. I just want to mention this. 2 to the n is not the same as 6 to the n. You see, the n has to be first. The exponents come before multiplication. So be careful, that's not the same thing. And you may, in your calculator, grab that the wrong way or something. So anyway, there it is. Our first term is 6. And hopefully you can see what I'm going to do. I am going to choose to multiply by 2 every time. Now you can certainly go ahead and write them all out, like a to the first is equal to, or the first term is 3 times 2 to the first power, and a, the second term, is 3 times 2 to the second power, and evaluate it. Even worse, you could put it in a calculator, but if you're really thinking, you can see that I need to multiply by 2 to get to the next term, which is 12, and times 2 is 24, and times 2 is 48, and times 2 is 96. And that's it. That's all you had to do, is multiply by 2 to get that geometric sequence. Now this one is an arithmetic sequence, and we start with a -3 minus 1. So we need to be careful. A to the 1, I'm just going to write my first term, is -3 minus 1, which is -4. Obviously, it's important that you know how to simplify expressions, arithmetic expressions with integers. So our first term is -4. And what this -3 right here tells us is that this sequence is going down negative, or it's going down by 3 every time. It's reducing it by 3 for each. And a way of thinking about it is the slope means the change in y over the change in x. Well, these terms are going up 1 each time, 1 and 2 and 3 and 4. So the y values are going down 3 every time. And that's another way to think of it. So this is -7. And if I go down 3 more, I'm at -10. And there you have it. Now we're going to do probably a geometric sequence this time. No, it's another arithmetic. And we're going to start with 4 minus 1, which is 3. Hopefully you guys can see it's 3. And I'm going to go up by 4. Now, I could do this: 4 times 1 minus 1, and 4 times 2 minus 1, and 4 times 3 minus 1. But what you'll notice is that each time I have an additional 4 that's being added in. Hopefully that also makes sense to you. This is the second term. This is the third term. And it can take you a while to do it that way. So what I'm going to do is I'm just going to add 4, which gives me 7. And I'm going to add 4, and that's 11. And if you look down here, you can see the 11, and here's the 7, and here's the 3. And if we add 4, we get 15. If we add 4, we get 19. There's our arithmetic sequence. And this one is going to be a geometric, and it's going to be multiplying by 3 each time. And our very first one, a to the 1, is 4 times 3 to the first, of course, which of course is 12. Now we're going to multiply by 3 each time. Don't let it freak you out. It's not that hard. We start with 12, and you can probably multiply by 3 in your head. That's 36. And if you multiply by 3 again, you get 108. And if we multiply by 3 again, 324, that's right. And if we multiply by 3 the third time, now this one's a little tougher. This is 972, isn't it? If you want to see the multiplying, we'll do it on the side. 324 times 3. Now we could have gone and, put these into our calculator and gone through all the rigmarole, but I'm hoping you guys can see how this works. 3 times 4 is 2, carry the 1. That's 6, and 1 more makes 7, and 3 times 3 is 9, which is my 972. Each time we're multiplying by 3, okay? In this one, we are going to increase by 49. Remember, this is not a geometric, this is an arithmetic. Now our first value, and again, this could get really ugly, okay? It's not that bad. And I'll show you a trick for what I'm going to do. I'm going to do the first one. Go ahead and write the first one. The first term is 49, 1 minus 76, and 49 minus 76 is going to be -27, I believe. And that's going to be our first term. A good idea is to go ahead and, here's how I did it. I took 76 minus 49 is really what I did. And that's the same as subtracting 50 and adding 1. Watch, minus 50 plus 1. You see, this is a lot easier, isn't it? 26 plus 1 is 27, isn't it? You could borrow and subtract and so on. But either way, realize the negative is on the 76 and the positive is on the 49. So it's negative 27. That's our first term, negative 27. Now, I'm going to go down, no, I'm going to go up, sorry, by 49 every time. Now, this very first time, it's going to be a little confusing because I'm going to add 49, which is really going to be the difference between these two, isn't it? Which is 22. And then we're going to go up 49 more, which is 71. And then we're going to go up 29 more, which is going to be 100. Oh, 49. Oh, what am I doing? We're going to go up 49 more, which is 130 maybe. And then we're going to go up 49 more, which is maybe 179, I believe. And a good way to check it is just to take the 22 plus the 49, which of course is 71. And if we add 49, we get 110 plus 10, which is 120. Ah, 120, oops. Nothing like adding an extra in there. And so then, of course, this is going to be 169, isn't it? That's what I get for not being careful. Anyway, you're more than welcome to, write it all out, and you can put it in the calculator. Another possibility is to actually use your calculator, and you can get the table settings and look at the table from 1, 2, 3, 4, and 5, and so on. But each time, there should be an increase of 49 each time. Increasing 49 is an arithmetic sequence. I would have been very surprised when I missed that one if I wasn't careful. Oh, this time we're going to multiply by 9. So we're going to start with 90 because our first term is this. Remember, you don't multiply it and then take the first power, although in this case, you'd get the same answer. But we're taking 9 to the first power, then we're multiplying it by 10, which is 90. And each time we move, we're going to be multiplying by another 9 because, and here's how you can think of it. A to the 2 is 10 times 9 to the second power. But that means 10 times 9, which was our original number right there, times an extra 9, isn't it? See that extra 9? Well, when I multiply by that 9, I get 810. And then I'm going to multiply by 9 again, which is going to be 72, 9 with an extra 0, isn't it? I just multiplied the 81 times 9, which is 729, and then put a 0 on it. And I'm going to multiply by 9 one more time. Let's go ahead and check my 810 times 9 since I'm being, I want to be overly cautious today. There's the 9 and there's the 7, there's the 7290. And we're going to multiply by 9 again. Normally, I really would do this in my head, but I am just not confident today. 9 times 9 is 81. Carry the 8, and we got a 6. Carry the 2, and we got a 63. Looks like. I'm just going to double check it one more time. 9 is 0, 81. Carry the 8. That's going to be 18, and 8 is 26. Carry the 2, and it is 65. That's why I like to check. Forgot to do my carry. 65, 610. Looks like that's probably it. You may want to grab a calculator and just double check it, but I think it's right. Okay, 3 to the n is 3 to the first is our first term, which is just 3. And then we're going to multiply by 3 each time. 3 times 3, and then 3 times 3 times 3, and then 3 times 3 times 3 times 3, blah, 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 blah. And we've got 3 for our first term. 3 to the first is 3. 3 to the second is 9. 3 to the third, hopefully you know, is 27. 3 to the fourth is 81. And there you go. So we're going to go down by 4 every time. And we're going to start with -3, aren't we? And then we're going to go down 4 to -7. And we're going to go down 4 to -11. We're going to go down 4 to -15. This is an arithmetic sequence where the kind of y values are changing by -4. They're going down 4 every time. Hopefully that all makes sense to you. Oh, we get, okay, now this one's going to be a little different. This one we can't just substitute it or imagine what's going to happen. We're going to have to substitute it in. So we've got a to the 1 is equal to -8 times 1 squared plus 3 times 1 minus 10. And that's going to be -8 plus 3 minus 10, which is -15. That's our first term. So our first term is -15. Our next term is going to be -8 times 2 squared. This is A2, by the way. Man, plus 3 times 2 minus 10, which is going to be -32 plus 6 minus 10, which is -42 plus 6, which is -36. Bit long, isn't it? Can't see a nice shortcut for it. Let's see. What's our difference here? We went down 21. Let's see if that has anything to do with anything. Let's see. Let's try a to the 3, A3. That's going to be -8 times 3 squared plus 3 times 3 minus 10. Well, that's -1, isn't it? And this is -72 minus 1 is -73. Well, that's going to be down 37. This one went down 21, and this one went down 37. Well, that's no help. Okay, let's do the next one. A4. A4 is going to be -8 times 4 squared plus 3 times 4 minus 10. And that is going to be -8 times 16, which is -128. I think so. And that's going to be plus 12 minus 10. So I'm really just adding 2, which is -126. That one had a change of -53. And is there a pattern here to these? Well, there's 26 difference here, and there's 26 difference here. So my guess is that this one is going to be down 79, if I had to guess. So if I'm guessing, I'm going to say that's going to be -205. Okay, so let's see if I'm right. A to the 5th, because math tends to work out kind of nice that way. So if you're wondering what I did, is I said the increase is by the difference between these two. It went down an extra 16, and in this one it went down an extra 25. Anyway, it's take a look at it, see if that makes sense. Let's see if it works. I still need to do A5. I guess I can just erase and put it over here. I'll put it down here. Sorry, it's such a mess. Of course, you could grab a calculator and do it too. I don't like calculators. A to the 5, A5, or the 5th term, is -8 times 5 squared plus 3 times 5 minus 10. So this is going to get, I'm going to be adding 5 here, aren't I? And -8 times 5 squared is 25. So that's going to be -200 plus 5. Oh, did I add wrong? That's going to be -195. Darn. Oh, no. Did I? It didn't work out the way I expected. So negative 195. I was thinking it was going to be negative 205. Was in there in the right vicinity. Anyway, I think those are correct. There is a way to test, and you could use a graphing calculator. It would go fairly quickly to make a table for this thing, but I'm just going to go ahead and go with mine and see if it's right. Looks good. Oh, this one's much easier. We're just multiplying by 8 each time, and we're going to start with 72, aren't we? And then we're going to multiply by 8, and we are going to get 576. And then we're going to multiply by 8, and we're going to get, oh man, 608, I think. Anyway, I'm going to multiply it on the side just to make sure. So I'm going to take the 72 times 8. And of course, I'm going to have the 6 and the 1, and that's going to be 576. 56 plus 1 is 57. Then I'm going to multiply that by 8, and I'm going to have 8 and carry the 4. And 56 and 4 makes a 0. And we have an extra 6. And 40 and 6 makes 4608. And then we're going to multiply that by 8. And we're going to have the 64. I don't have to worry about the carry or anything because of the 0 there. I have an 8 with a carry of 4. And that's going to be 36, isn't it? So I have 36, 864. Looks good so far. Double check 64, 48, and 36. Yep. Okay, so I have one more. I still have to multiply by 8, and I'm sure some of you have already grabbed your calculator to multiply it out. That's 2, 3, 48 and 3 makes 51, and 5, and 9, and 6, and man, 4, and 5, and 29. Okay, I am going to grab my calculator and check my work. I think it's right, but who knows? Okay, so I'm going to check it. 576, I know is right, times 8 equals 4608. Times 8 is 36,864. Yep. Times 8 is 29,4912. Yep. So we put them in. Just got to be careful when you put them in. That's going to be 72, 576. Probably wouldn't hurt to go ahead and jump into a calculator. I would do that, but I just don't assume. I'm just not assuming that everybody has a like a graphing calculator online handy and stuff. So I think this is fine. 4608. It's more fun doing it by hand anyway. I think my next one was 36,864. I'm going to double check it just a minute. And my last one was 294,912. Okay, 29, 49, 12. Yep. 36,864. Yep. 4608, 576, and 72. Okay, there they are. We had to multiply by 8 each time in our sequence. Man, they're really making us work for this, aren't they? Okay, for those are for geometrics. Oh, now this isn't so bad. Okay, find the 6th term. Now there's a way to do this using the formula. There's recursive formulas and there's explicit formulas, and we could do it that way. I'm going to go ahead and just write them out and show them to you because it's really not that hard. So 8 is our first term, isn't it? And then we're going to multiply, we're going to add 8 actually each time. And there, it could get confusing because 8 to the n, we would be multiplying by 8 each time. And 8n means we're adding 8 each time, which is 8 times 2 is 16. And 8 times 3 is 24. And 8 times 4 is 32. And 8 times 5 is 40. And 8 times 6 is 48. Now, you might have guessed that we were going to go, the 6th term would be putting a 6 in for n, and then you would just multiply it and get the 48. But I wanted to make sure that you thought about it, that this is the formula, isn't it? For a to the 6 is 8 times 6. I just wanted you to see that it works, and we get the 48. Okay, I guess that's what we're talking about. Just making sure. Okay, now this one is a little more confusing. It says n represents the position of a term in the sequence, and we want a to the 6th. So basically, if I say a6, notice I'm replacing the n with a 6. And so I have to replace that n with a 6. But be careful. It's now 6 minus 1, which is really to the 5th power. So I have 4, and I'm going to write it all out to 6 minus 1. Now you do have to do this. This is assumed to be in parentheses since it's up above in the exponent. They didn't put the parentheses around it, but you see how they wrote it smaller. So we have 4 times 2 to the 5th power. Now, a lot of people are going to think this is 10, and that's not 10. That's 2 times 2 times 2 times 2 times 2, which is 32. So we have 4 times 32. Don't multiply these first and then take them to the 5th power with your calculator. The exponent comes first, doesn't it? And 4 times 32 is 128. And then you're done, okay? Okay, this is called an explicit formula. That's what this is called. A recursive formula has a to the n minus 1 in it, which means you use one of the last term you use it to find the next term. But this is called an explicit formula. I'll write it out for you. Hopefully my spelling isn't terrible. I always add an E, and I'm never sure whether to add the E or not because a lot of my schooling, at least a good part of it, was in Australia. And so they used English spelling. So it could be, sorry, I apologize in advance. It could be explicit. It might be with the E. Poor Walter Mondale went in and spelled potato with an E, and it basically lost him the election, which is really sad. It's so weird. Anyway, there it is. It is an explicit formula. And we have a to the 8 is equal to negative 2. The negative is important, but keep in mind that the negative is going to go on after we take the exponent. And that's important because if the negative were inside the parentheses, then it would alternate between negatives and positives. As it is, we know that the answer is going to be negative. There is no possibility. There's no other possibility. Now, the n is 8, and we're subtracting 1. So now we've got negative 2 to the 7th power. But be careful. If you just stick negative 2 to the 7th power, you will happen to get it correct, but it's just by accident because this really is that, which is a different thing. So be careful. 2 to the 7th power is 128, so we have negative 128. And I'm just going to go ahead and write that out just so you can see it. We have 2 times 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 2. There are 7 of them. Well, we already know that this is 16, don't we? And we know this is 32, and we know this is 64, and we know 64 times 2 is 128. And don't forget the negative. There we go. Okay, I'm going to go a little faster this time. A to the 8, the 8th term is going to be 6 times 2 to the 8 minus 1. Well, we already know that 2 to the 7th power is 128. So I'm going to take 6 times 128. And that is going to be 768, isn't it? So let's multiply it on the side. 128 times 6. We get our 8 and carry our 4. And that's going to be 12. And 4 makes 16. And carry our 1. And that's 768. And it is positive. Nothing to be afraid of, just substitute and simplify, okay, guys? Oh, 67th term. I don't think we want to write them out. So this is the formula. The A term, the A to the N term, is given by N plus 38. So a to the 67th term is 67 plus 38, which is 105, isn't it? And we're done. If you want to put it up here and add it, that's 5, and carry the 1, that's 105. Okay, so we have AA4, or the fourth term, is negative 33 times, negative 2 to the 4 minus 1. There are all kinds of ways to get this wrong. And by hand is a lot safer than messing with your calculator. Because if you fail to put the parentheses in the right location and just start typing, your calculator may do what you tell it, which is not necessarily order of operations. This is negative 33. 4 minus 1 is 3. You don't need your calculator for that, just a hint. You do have to do the exponent first, because if you start multiplying in your calculator, negative 33 times negative 2, and then take that to the third power, it's going to be way too big. Negative 2 to the third power is negative 8, not negative 6. Be careful. That is negative 2 times negative 2 times negative 2. And when you multiply that, it looks like 264 maybe. Let's double check. Now I'm multiplying the 33 times the 8, because a negative times a negative is a positive. That is 4, carry the 2, and that is 24 plus 2 more is 26, 264. And it is positive, isn't it? Be careful. Easy way to make a mistake. There's lots of mistakes waiting for you. All right, this one's not so bad. The seventh term, is 9 times 7 minus 4, which is 63 minus 4, which is 59, isn't it? Looks good. We're getting there. Okay, explicit formula again. We want A5. We want the fifth term. So we have 7 times 2 to the 5 minus 1. That is 7 times 2 to the fourth power, which of course is 16. You do have to do the exponent first. That's 7 times 16. And that's going to be 112, isn't it? Let's multiply it over here just to see. That's 2, carry the 4, and 7 and 4 makes 11. That's 112. And no negatives in there. Okay, we've got A7 again. It's not the same one though. It's 14 times 2 to the 7 minus 1. I guess it wasn't A7 last time. This is the seventh term. We have 14, and we're talking about 2 to the sixth power, which is 64. And I'm going to take 14 times 64. And what's that going to give us? I don't want to do it in my head. I'm going to write it down. That's 6, 1, 25, and 640. So we got 896. How did I know that 2 to the sixth was 64? Well, the way I did it was 2 to the third times 2 to the third. Notice that you add exponents. This is 8 times 8, which of course is 64. That's how I knew that one. And 14 times 64, I'm going to check it with my calculator because I'm getting close to the end and I really don't want to do this again. And it is 896, of course, as expected. There we go. Okay, we're taking the sixth term. We're talking about negative 3 times 2 to the 6 minus 1. I want you guys to memorize some of your powers of 2. They're very useful. 2 to the fifth power is 32. So it's one of those that's really nice to memorize. That's going to be negative 3 times 32, which is negative 96. And sorry, that's an ugly looking 6. There we go. A little better. And it is negative 96. Looks good. Got to do a lot of these, don't we? 29th term. So we're talking about 38 times 29. So it's a to the 29 is 38 times 29. Is there a nice way of multiplying those? Not really. I mean, I could multiply it by 30 and then subtract the 38, but it's just as easy to just go ahead and multiply it out. That's 2 carry the 7. That's 27 and 7, which makes 34. And we have a 6 carry the 1, and that makes a 7. So we got 1, 1, 0, 2. Let's check it. $11.02. N plus 27, 95th term, that's going to be easy. A to the 95 is 95 plus 27, of course, because I'm substituting for the n. And of course, that's going to be 122, isn't it? And negative 100n is negative 4900. I'm going to be lazy and just put it in. 49 times 100 is negative 4,900. And 4, we're going to put the 4 in. So we have A4, the fourth term, is 4 times negative 4 to the 4 minus 1. It is really easy to make a mistake right here. Negative 4 to the third power is negative 64. It's kind of a tough one. That is negative 64. We're talking about 4 cubed. It's really negative 4 cubed, so it's going to be negative, but it's going to be 4 times 4 is 16 times 4, which is 64. And it's negative 4 to the 63rd, like this, which is negative 64. When you multiply negative 64 times 4, you get negative 256. We could multiply it on the side, but I know it's right. Looks good. We're getting there. 2 more, looks like. We're talking about a to the 6th term, which is, I don't want to say it's a to the 6th. It really isn't. Negative 3, and we're talking about 6 minus 1. So we're talking about 2 times negative 3 to the 5th power, and that's 2 times negative 243. And we are going to get negative 486, aren't we? Okay, now where the heck did I get the negative 243 from? I happen to know that 3 to the 5th is 243. And the reason I know that is because I know that 3 to the 4th is 81. And if I take 81 and multiply it by 3, I can basically do it in my head. That's 3 and 24, 243. One of those that you kind of want to remember. And because it's negative, the 5th power ends up being negative. And then I multiplied them together, negative 486. Looks good. And one last one. And it looks like a nice power one. Looks like we have an A to A5. So we're taking the 5th term. And we've got negative 7 times negative 3 to the 5 minus 1. That's negative 7 times negative 3 to the 4th. Now you need to be a little bit careful. Negative 3 to the 4th power isn't negative, but a lot of people are going to get this one wrong, because what they're going to do is they're going to do this. They're going to say, I'm just going to put it into my handy dandy calculator, and your calculator is going to say, that's negative 81. And then they're going to multiply that by negative 7, and they're going to get it wrong. The problem is that this right here is not the same as this. This says Negative 3 to the 4th power is this. And that is, just like your calculator says, negative 81. But that's not what that says. This says negative 3 to the 4th power says negative 3 times negative 3 times negative 3. And notice that that is a positive. That is positive 81. That is being multiplied by that silly negative there. And that's negative 567, isn't it? And I'm just going to multiply it on the side to show you. It's times 7, and we have a 56, and it is end up being negative. Negative 5, 6, 7. And it looks like we're done. And I hope you guys will try it yourself and get your mastery. I'll see you again sometime. Bye-bye.